You are acting sus, and in order to catch a blue before they hit the emergency button, you have to take the quickest path to get them. If they are 12 meters west of the button and you are 8 meters directly south of them, what is the shortest path you could take to get to the button just before they do? Okay, so I know you could probably report it and chance your luck that way, but for the sake of the problem, let's work through this. All right, so blue is 12 meters west. You are 8 meters directly south. So all we got to do is plug it into the Pythagorean theorem to find the resultant. So 12 squared plus 8 squared is equal to c squared. So 144 plus 64 is equal to c squared, of course, but c will be equal to 208 is equal to c squared. Square root of that gives us an answer of 14.4, I believe. Yes, 14.4. So c is equal to 14.4 meters. All right. I think that's just about it. Hope you liked the little Among Us problem. And, yeah, enjoy. After beating the Bucks, Jimmy Butler celebrated by dribbling for 10 minutes directly north. Then he turned west and dribbled for another 5 minutes. If you needed to catch him and could run at the same speed as he dribbled, what is the fastest time you could travel to reach him if you started from the same place? Okay, so we know this is kind of similar to other problems that we've already done, but this time with time involved. You can replace them as long as it says something like traveling at the same speed. So Jimmy Butler went north 10 minutes. All right, and then went west for another 5. So we need to calculate. I don't know why it's so slow right now. Oh my goodness. Come on, computer. All right, we need to calculate c. So c right here. So if we plug this in, a squared plus b squared is equal to c squared. So 5 squared plus 10 squared is equal to c squared. So that would be 125 is equal to c squared, square root. Square root of 125 is about 11.2 minutes. So you would have to run for 11.2 minutes. You could start after a few minutes after you'd already started running, but you need to catch him by running at the same speed as him in that amount of time. That's all the time you got. But it is shorter than the path that he traveled. All right? So, move on to the next problem. Let's go. Okay, so here are the answers to the centripetal acceleration problems. A Ferris wheel has a tangential velocity of 4.5. So we know this is 4.5 vt. Its radius is 31 meters, so that would be r. And we're looking for centripetal acceleration because it is highlighted in orange. Okay, r is equal to 31 meters. All right, our unknown, as I was saying, was centripetal acceleration. Ooh, that's pretty close. AC is equal to question mark. The only formula that we know is AC is equal to VT squared over R. So if I plug that in, AC is equal to 4.5 squared divided by 31, which is equal to 0.65 meters per second squared. Moving on to the next one. Okay, a pitcher throws a softball with a centripetal acceleration of 1400 meters per second squared. So this right here is my AC, not my tangential velocity or anything. The length of her arm is 0.8 meters, so that would be the radius in which the ball travels. So that is r. What is the tangential velocity of the ball? So I know this is a really crazy high number, but trust me, there is a lot of force put into those swings. Okay, so the length of our arm is 0.8. Let's write it down. R is equal to 0.8. AC is equal to 1400. And tangential velocity, again, is equal to question mark. All right. Our equation is AC is equal to VT squared divided by R. This one, again, tricky just because you got to make sure that you put it in the correct spots. So 1400 goes over here, not at where VT is, because that's what we'll be solving for. And this is equal to 0.8. So in order to get 0.8 to the other side, we got to multiply it to cancel it out over here. When you cancel it out on one side, you multiply it to the other. Because whatever you do over here, you have to do to the other side. 0.8 times 1400 is equal to 1120. 1120. So the VT squared, square root. So if we square root that, that will be equal to 33.5 meters per second. 33.5 meters per second is equal to VT. Now, we want to do a conceptual problem. If a tennis ball on a string is traveling clockwise, like in the picture below, draw the direction the ball will travel in. If the girl spinning it, release the ball at that point. So right here, we know the ball is spinning in this direction because the arrows are pointing that way. Clockwise is to the right like this. Counterclockwise is the other direction. So all I gotta do, find the tangent and draw a straight line. That's it. That's the answer. If it was going in the opposite direction, let's say it was going counterclockwise, the ball would go like this. And the centripetal acceleration is always directed inward. Okay? That's it. You got it. So the trick with this problem was understanding that the hint that I was trying to get you to understand is that there is something that's always directed towards the center of the Earth. We know it as gravity. The acceleration due to gravity is equal to 9.8. So technically speaking, if an object is orbiting around the Earth, that acceleration due to gravity is also the centripetal acceleration of anything orbiting Earth. So the radius of the Earth is about 6,370,000 meters. So this is my R, okay? R is equal to 6,370,000. 70,000. Yeah, I think that's right. One more zero. Okay. What is the speed that Bugs needs to throw the ball at in order for it to travel around the world? So if you were to throw it any slower than the speed that we're solving for, it would not make it all the way around and would in fact come back down somewhere on Earth before it reached Bugs. So we are looking for VT. Because we're looking for a ball is traveling like this. Obviously not that far, but it's more like right up against the Earth's surface. It will be traveling like so, all the way around until it reaches Bugs again. All right. So in order to solve for this, we use our equation of A is equal to VT squared over R. Then I know I'm kind of running out of room. Hopefully you didn't. It's okay if you kind of cheated a little bit to get more room. Like you didn't write all of these steps and you just started here. That's fine. So 6,070,003. All right. In order to get VT alone, I've got to multiply the 6,370,000. I don't want to rewrite it. So I'm just going to do bop, bop. I'm going to say it's R, R. Cool. So Then I have 9.8 times 6,370,000, 62,426,000. That's it. No other things. Is equal to VT squared. All right. In order to solve for VT, we just got to square root both sides, and we get our answer equal to 7,901 meters per second. So in case you're wondering, the International Space Station is traveling, I think, a little bit faster than that because this is an approximation, but really close to about 8,000 meters per second. So if it were to slow down at all, the ISS would actually come crashing back into Earth. If it went any faster, it would launch out of orbit and travel in a straight line continuously until it hits some planet, some asteroid, or maybe it never does and it just keeps floating in space. All right, so that was the hardest problem I've given so far. Hopefully you were able to do it without my help. If not, that's okay. It's tricky. So go ahead and start working on the worksheet, get some practice in, and then ask me for any help. Please, please, please make sure you took notes on all this stuff because we are having our test Friday, okay? It's very important that you took notes, as always. Bye!